be any second now.
Oh, yeah, any second, boy, I tell you. We are, amazingly enough, thanks to AI, on the air again. Time again for the SBA, that's Santa Barbara Astronomical Units, South Coast Longtime Astronomy Telescope Club, to gather together on screen for our weekly Monday morning blog podcast we call the SBAU Astro Hour. I'm Ron Herron, your host, and proud to be on the board of the club. There's a lot going on these days, cutting edge cosmology all around us, everybody. And we get full houses on our first Friday meetings, new discoveries, new theories, NASA launches, and incredible space telescope pictures. And we talk about it all right here every Monday morning. This is number 118. Wow, that's over 2 years. May 22nd, 2023 to the 28th in 1 week. Let me get that ad off my screen. And my name is Ron Herron. We're going to talk about one of the planets, where they're going to be in the merry month of May, or what's left of it. The moon, of course, is in waxing crescent. We'll have two views of Jupiter this week to talk about. One is with our own scopes, checking out its moons. And the other is a close-up of Io, that volcanic little sucker around it, taken by the Juno orbiter. Globular cluster of the week is M4, named by Messier. What's the oldest things we can see in the sky, other than our president, who's out there in the back? And planetary nebula named Helix, and comets, and Saturn's moon, and Helene, and the novas, and all kinds of silly stuff that we're going to watch here in a minute. Here's Jerry Wilson, our beloved president, in all his white hair.
Good morning.
I'm sure glad the rest of us don't have that color hair. His wife is Pat Forgy. And he is a president now going on 6 years or 7 or 5. I lose track, you know. We made it through the pandemic. And
2017 was my first year as president.
That's 6 years. Wow. Chuck McPartland, I think, has been our outreach guy, plus everything else on the board forever. How many years for you, Chuck? You know.
Oh, 80 something, late 80s.
So clear back before it changed its name.
Well, no, we've always been called the astronomical unit.
I thought it. No, you've told me that it had another name at one
No,
time.
there. Well, okay. So way back in 1955, there was the Santa Barbara Star Cluster,
Okay.
which then eventually became the Santa Barbara Astronomy Club. And in like 1995, they merged with the astronomical unit.
And down at Ventura, it's VCAS. They just stuck with Ventura County Astronomical Society, didn't they?
VCAS,
Right.
yeah.
All right. Here's Tom Whittemore, our former
Right.
Westmont College retired instructor in his own lab, and he brought it all home and it turns it into incredible bread in his kitchen. Editor of the newsletter, and it's us four this week to talk about these goodies. For some reason, I didn't end up with a lot of notes on cartoons. Did you send less, Jerry, or do
We only have 2 cartoons this week. I don't go hunting them up. I just
I sent you one.
get them if they come along.
I've sent you one that was sent to me, but one of our viewers, Tim Crawford, enjoyed it. Here we are, the stick figures.
Yeah.
Talking near the stove. Next, he says, we heat 4 cups of heavy water over very high heat until it thickens, and hey, it becomes rich in iron. I feel like I'm Neil deGrasse Tyson here, getting really into fusion cuisine. Okay. Cold fusion would be next. What is this? 1 day on Venus lasts 5,832 hours, equivalent to a Monday here on Earth. I need some explanation on that. It's not tidally locked, though, is it? Venus. That's not a tidally locked thing.
Tidally resonant.
Tidally resonant. Okay. So is this the other one? The only other one we got?
Those
Okay.
are the only 2 that happened across my desk this
Well,
last
check out
week.
the forwarding I gave you about the dog talking about a light year. Tim Crawford said, I like that one. And I sent it to everybody. We're going to talk about things in the sky. And I guess they just launched. They did 2 launches. What, last week they launched from Vandenberg. And then yesterday or Saturday, they launched 4 astronauts up to the space station from Canaveral, didn't they? A lot going. Who's joining us on? Oh, there he is.
Bruce.
Bruce.
We also have Tim.
Is watching.
Tim is watching, plus 3 others, or he's one of the 3, maybe.
Well, Tim is one of our far out supporters. And here we go to the planets in the sky. Who wants to go down this?
a quick view of where everything is and dashing your hopes to see them in the night sky with your amateur telescopes.
Mhm.
Mercury is on May 1 was in conjunction. It's now in the morning sky. It's low in the east.
Right.
Venus is the stunning thing in the sky at night, in the early evening,
Right, right.
playing with the
right.
crescent moon right now.
Yeah, right at the belly button of Gemini.
Yeah. We're past the spring, the vernal equinox, and we're heading toward the
Solstice.
summer solstice. Yeah.
I'm glad you posted that one, Jerry. I always want to know where the hell the planet is that I'm on.
Oh, right. We're still cruising around the sun.
Yeah.
Mars is in Cancer and drifts closer and closer to the famous beehive cluster. It'll be in there about June 1 or June 2. Great photo opportunities.
Mhm.
3 degrees.
Jupiter sits about 10 degrees above the eastern horizon. It's now a morning object
Mhm.
before sunrise at the end of May.
Wow.
Saturn is up about 1:30 a.m. By the end of May. It lies in mid Aquarius and is by far the brightest object there. So you'll have no trouble picking that up. Uranus is also a morning object. Most of the planets have gone to the east and they're starting their western trip across the sky.
Mhm.
Same with Neptune. But Pluto is up, rises just after midnight and is in Capricornus. It's a faint object. You're going to have to dig for that one. Bigger scope.
Have any of you ever seen Pluto in your
Yes, I have.
scope? Really?
I have.
Was it probably not much more than a pinprick of light, though, isn't it?
Yep.
It was,
Can't tell it from a star, except it'll be in a different place a week
I
later.
saw it in a 61-inch in Tucson,
I'll be damned.
Oh, wow.
like a
That's bigger than
star.
I thought.
but it looked like a star.
I had to use a camera.
Oh,
Looks like a fuzzy star.
And only with New Horizons did we learn it had a huge heart on its surface.
Yes.
A heart of
So this
nitrogen.
is the moon phase for this month. We are here on the 22nd, and this is, you can see the Earthshine very nicely. Someone posted a picture on Facebook of Earthshine, a very nice photograph. Of course,
You
the
know,
bright
now
sun
you know
department.
how lunar eclipses became blood moons, and all these
Mhm.
lugubrious headlines. Well, now Earthshine is being called Da Vinci Glow.
oh no.
Yeah.
I hadn't heard that. I've always heard it called the old moon and the new moon's arms.
Yes. Mhm.
Did the ancients know that it just didn't go black like the night sky when it was mostly covered? Did they know that it was still there?
Sure.
Did
Yeah.
they? But not
Yeah.
as much.
So
I was going to say we caught our first glimpse of the brand new moon about a day after new. It was Saturday, and very, very nice little chip of moonshine on the moon, well below Venus. It's crawling up towards Venus now, in Gemini. But you have to remember too that when you see the moon this time of the year, it looks like a little smile in the sky because of the inclination of the ecliptic, okay, with respect to the horizon. Okay.
That almost looks like the stick figures in that first cartoon we just saw.
could be. So there's the belly button. There you guys. I guess it's like the three witches. They have to share an eye. Here they share a belly button. So the moon today and then going on up later this week.
Mhm.
This is the period from new moon or old moon, excuse me, what is the
Third quarter.
third quarter, thank you.
Mhm.
Third quarter to first quarter, this is when you can find a dark part of the sky to take astrophotos.
Mhm.
From these parts of the month, it's usually hopeless. You have to take pictures of stars or star clusters. So
That's not so bad, Jerry.
so I'm predicting that the weather will clear. So
Yeah.
it's overcast here, and then
Yeah.
it'll clear up and the moon goes around full.
Yeah, I was just going to mention Saturday night, it was just absolutely beautifully clear here. And so
Yeah.
I pulled binoculars around 9 o'clock. And, after I enjoyed, Venus and the little moon and stuff like that in the western sky. I took the binoculars and headed towards Boötes. I got M3 easily in the binoculars. M13 was up in Hercules. And it surprised me that by 9 o'clock, I could see Antares crawling up in the southeast. It's really
Summertime's on the way.
Yeah. I tried for M4, which I know is part of your thing today, Jerry. But it was still kind of getting clobbered by the fog, if you like.
Charles Schuler and I went up to Figueroa Mountain on Friday, and we looked down on the fog. We had wonderful viewing.
Yeah.
I could
That's
see
what you're pointing.
M13, M5, M4, a lot of stuff.
Mm-hmm.
Well, the two questions I have about the ancients are about, let's see, Pollux and Castor are the two Gemini. Are they boy and girl, male and female, or
No, they're
Two
twins.
They're twins.
Boys.
twin boys?
They're
Yeah.
identical twins.
And the word waxing, is that ancient Greek for filling
No.
up?
No.
German.
What's a
German
German?
voxens to grow.
I'll be damned.
And when the moon wanes, it's Venen in German, which means to go weaker.
Yeah, their V's and W's are pretty much alike, aren't they, in pronunciation and spelling?
And gibbous,
Well, there's an umlaut there, so be careful.
Yeah.
and gibbous comes from hunchback.
Right.
Hunchback.
Yeah.
Mhm.
A
That,
gibbous
I believe,
moon
is Latin. That's a Latin root, I think.
So
We
if
get
you're in Germany and you want a BMW, they don't call it that. It's a BMW.
All
Or a
right,
beamer.
Beamer, yeah, no, yeah, a Beamer. So what's the oldest thing you've ever seen aside me? So,
3C273.
Yeah.
the heck is that?
So
It's a quasar.
quasar.
Oh,
and you've seen it?
Yeah.
Yep.
Seen it in an 8-inch.
How old is it?
2.4
what's it?
billion.
Yeah. Yeah, it's about 3 billion light years out, right, Chuck?
Yeah.
and you've seen it, and is it in red, ultra, or
No,
intra?
no, it's just a dot. It's just a bright dot.
It's a little dot.
Yeah.
But if it's that far away, why haven't the light waves shortened?
They
It's
have,
shortened,
but
but-
not so you'd see visually.
Right.
Oh, okay. All right, where are we then? This is west sky, western?
Eastern.
Looks like
This shows,
M3.
this is the sky around Arcturus, and it's a very densely populated sky with a lot of Messier objects up here, which are easy objects.
Mhm.
So it's a good part of the sky to explore, but it's here because of Arcturus,
Mhm.
and which is Arcturus is
An orange giant.
one of the, yeah, it's an orange thing. It's a population 2 orange giant, and it's about
Mhm.
7 billion years old.
Mhm.
That's not the distance from us.
Right. It's about 40 light years out.
Yeah.
Around 37. That we did an outreach in Los Olivos the other night on Saturday night. And the fellow that asked us to come out just for fun, I knew it was his birthday the next day. And I said, well, how old are you? And he said, oh, 37. And it's like,
Beautiful.
whoa, Arcturus right there. There's your
Yeah.
birthday star.
When you were born, that light started, huh, Chuck?
So
It's-
Arcturus is visible because it's fairly close to our sun, and it is passing through our region of the sort of an interloper star, passing through the bubble that the solar system is in. So it's a very interesting star. It's not moving real fast like Barnard's star or anything, but it's
Mhm.
a nice population 2 orange giant.
Well, forgive me for not knowing, but it would thus be on the ecliptic and be part of a constellation in the zodiac, which
No.
is,
No.
it's not in a constellation?
It
It
is.
is
It's
in
in
a
both.
constellation. It's in
It's
Buddhas
the-
right there.
Star and Boötes, the herdsman.
See Buddhas.
But if it's
Well,
near
There's
the sun,
Arcturus right there. Oh,
okay,
it's covered up.
got it.
And I was
Okay.
mentioning earlier that there's M3. Can you see that, Ron, above Arcturus?
Yeah.
It's a beautiful globular cluster.
Right
Easy
there.
to pick off with binoculars. Easy.
I think it's one off from our, the one we're gonna talk about today. That's M4, I believe.
Yeah.
Yeah.
that-
Yeah,
Yeah,
we're going to
that
talk
sounds-
about M4 right now, and that's another distant object. The reason we're going to talk about M4 is it was the subject of a study of white dwarfs in the star cluster by the Hubble. And white dwarfs allow them to determine the age of the cluster.
Mhm.
And so, when a white dwarf, as they say, white dwarfs got no heat, that they don't have a source of heat. They are just coasting from when they used to do fusion. And now they're just simply, anything they generate is from gravitational collapse, which forces the atoms together and they friction off each other. And it's leftover heat that hasn't escaped from the star yet. It takes hundreds of thousands of years for a photon to get from the core of our sun to the surface. And so even if the fusion at the core stopped right now, it would still shine for quite a long time.
And
White
it's so
dwarf-
much denser in a white dwarf that it takes even longer.
Yeah.
Which means we can't see them, can we?
Yeah, we
They're
can.
very hard to see. They're very dim. M4 is close enough that Hubble was able to pick them up. I think the brightest one is somewhere around 15th magnitude.
Okay, so that's different from a neutron star, which might be 10 miles across, but a white dwarf's a little bigger, a lot bigger, I would
Yeah.
think.
Like Earth-sized.
Oh, geez.
So this is the constellation of Scorpius here.
Mhm.
Show a little more of it. The claws, which used to be up here somewhere. Going down, there is Antares,
Mhm.
which Chuck has convinced me means anti-Mars.
Rival of Mars. Yeah.
Rival of Mars. Okay, yeah. M4 is right off of Antares, easy to find, easy to see.
Yeah, it's kind of like a corner of a triangle formed by Antares and that star up on Scorpius. Right there.
Right
See the
there,
little
a
triangle?
Yeah.
That's how I find it in binoculars.
And the
Okay.
two claw stars are the ones with the long names up there, Zubin el-Janubi and Zubin el-Shamali.
Yeah, that's Zubin el-Shamali, and this is Zubin el-Ganubi.
But they've found that it has far more white dwarfs than most other globular clusters.
No, it doesn't have less of them. It's just close enough that they are so dim that you could see them. Some star clusters are farther away and the stars are so faint you can't see enough of them to study them. When I was a kid, we went to the Griffith Observatory, and the guy that did the planetarium show there told the audience that he received a phone call and someone wanted to name their twins after stars and give them stellar names. And so he recommended the two Zubin el-Ganubi and Zubin el-Shamali. I don't think it was quite what anyone wanted, but
Instead of Castor and Pollux.
yeah.
Yeah.
So this is white dwarf stars in M4. This little region right there is blown up here. These circles are around individual white dwarfs.
Wow.
So if you didn't know they were there, you could really miss them.
Yeah.
Yes, well, they were specifically looking for them. It was a study.
Okay.
Now, these things, they're coasting again, so you can tell how bright they are. You know how far away they are because they're in the star cluster. So you can tell how far along they are when they became white dwarfs because they're cooling down at a certain rate.
Are they on their way? Are they on their way to becoming black holes?
They're on their way to just
no,
becoming
no.
dark stars.
Okay,
Big clumps of material.
later on in the show here, if we get to it, we're going to talk about novas, supernovas, hypernovas.
Novae.
They're all this is all the result of a nova of some sort. Only one
No.
kind though, right?
No.
No, they're not. They're not supernova. They're not. I thought you just said they left over from explosions.
So Ron, this is what our sun will finally fade to, one of these.
Yeah.
You mean it'll all just collapse on itself? It's not going to have an explosion.
Right.
No, it's going to have sort of a burst.
It'll
The
burst
big
off
burst.
its outer layers.
It'll do a planetary nebula phase
We'll
where it
get to
bursts out its
that.
outer
We'll get to
layers.
that in another slide or two here.
Okay.
But back in the 1800s, Boltzmann had worked out partial things about thermodynamics, heat conduction, and heat loss. And so he tried to calculate the age of the Earth from assuming that it was once molten. And he started with the Earth being a uniform ball of molten lava at about 2,000 or 3,000 degrees. And then he calculated how long it would take for the Earth to cool off. And he made a fairly rational estimate of the Earth's age, but it was far too young.
Mhm.
because at that time in the 1800s, he did not know that the Earth had an extra heat source in it. And that was residual radioactive materials that were still providing heat for the surface or for the Earth. Had he known that, his mathematics would have come up with about the correct age of the Earth. So what we're doing is these are like Boltzmann stars. Of course, they have radioactive material in them too. So these are just, but we know the math of that. That's very straightforward. It's deterministic. So we can tell how old each of these stars are. That's
So
what
we
gives
apply
us,
the fourth power law to figure out the age then?
what's that called?
You know, radiative heat goes as the fourth
Yeah.
power. Difference
Black
in the-
body radiation, Wien's law.
Wien's law. Thank you.
Yeah.
Yes.
Yeah, that gives you the wavelengths, but
Yeah. The peak wavelength.
yeah.
Yeah. They're
So the cores of these stars are often around 100,000 kelvins, so they
Mhm.
broadcast really, really hot in the UV, the ultraviolet. Of course, this is, I guess, Jerry, visual, right? Optical.
Yeah, this is an optical telescope with
Yeah.
yeah, and sort of Bruce has right there as the thing cools off, its peak radiation moves out to the infrared. So if you do a broad spectrum of it, you can tell what the surface temperature of the thing is, and therefore how it's doing on its coasting heat.
Oh, can you go
So-
back just for a second to the M4 picture? Yeah. So kind of squint
Oh,
at the picture on the up.
Yeah.
Yeah, kind of squint at the picture on the left from the ground-based image, and you can see there seems to be a bar. It's not quite vertical. It's a tiny bit offset to the left, but you can see kind of a bar going through it if you squint.
Huh.
A brighter
Oh,
star.
through here,
Yes,
there?
yes.
Oh,
No,
yeah.
going up and down, kind of.
So clusters have bars?
Well, Ron, just a second. So you can see it looks kind of like a bar going up from the 5 o'clock to the
this?
11 o'clock position if you squint.
Yeah.
And that's kind of obvious in some small telescope views of M4 because you're not getting all these
Huh.
other stars like in this image.
Mhm.
And so it's called the cat's eye.
Mhm.
Oh, huh.
Okay.
You know, if I squint, the whole thing looks like a Pac-Man.
Yeah, with his mouth up top.
Yeah.
Yeah.
Okay.
Oh, yeah. Huh. How about that?
Well, just a stupid question off to the side you can throw away real fast. Any exoplanets around these little suckers? Would they do something different or go away or be sucked in?
In
Or
this kind of environment, this is a hostile environment for forming solar systems because the suns move a lot in chaotic method or patterns, and so they would steal planets away or perturb them into being thrown out into the space. So
And in addition, these stars are metal poor. Okay. These are stars that formed very early. There weren't so many heavy elements. And so you don't have rock, you know.
Mhm.
You might have gas planets. And there has been a planet found in a globular cluster, but it's a case where it's a neutron star in the globular cluster.
Hmm.
So it was one that was more massive, or maybe a blue straggler that subsequently blew up, left a neutron star, and then that neutron star, some debris from the explosion formed around it.
first two elements in the periodic table are gas, and then the third one is an element, isn't it? Lithium.
It depends on the temperature you're talking about, whether anything is a gas or a solid or a liquid or a plasma. They they each can be in any one of the four phases, depending on their environment.
Isn't it interesting? Sure. Okay. Well, those
Okay, we're going to move to our twin planet because I found an interesting picture online.
Aha.
This is Earth has sometimes been called our twin planet. It's very
Wow.
close in size to the Earth. It's basically 95%. It has 90% of Earth's surface area, and it has gravity that is 90% of what. So you'd weigh about the same thing. You'd be a little pleased with your bathroom scale, but you'd get over it. Fill back up. The composition of our two planets is very similar. Both have metal cores surrounded by a mantle of silica rock and then a thin crust. In both cases, the ratio of the crust of the planet to all the molten and fluid and plastic stuff inside is the same as the proportion of an eggshell to the inside of the egg. So we're riding on a thin crust.
Huh.
Don't break the shell. The differences are, but they're core differences because the Venus, of course, has this hellish atmosphere of acid and CO2, and it has 90 Earth atmospheres worth of pressure and something like 800 or 900 degrees. What is it, Celsius or Fahrenheit?
That's Fahrenheit.
Fahrenheit on the surface. But the Earth's core has convection, which regenerates our materials with the atmosphere. It generates our magnetic field. Venus does not have a similar magnetic field, and we assume it doesn't have internal convections to get that dynamo going. Earth has plate tectonics. There is active geology on Venus, but it's not plate tectonics. It's presumed to be just volcanic flows.
Well, is it possible to blame part of that lack of a magnetic field on a very long day, the rotation of the
Yeah.
planet? Doesn't that help?
Yeah.
That helps.
Mhm.
So I
Actually,
still
it
don't
helps
totally
really.
understand. Is it going in the opposite direction as our planet turns?
Yes.
It is.
Yeah.
What the hell happened there?
But very
Got
long,
whacked by something that flipped it over.
Oh,
same as we got whacked and gave us our 24-hour day.
and does plate
And
tectonics,
our
on the-
moon, right?
In our moon.
Yeah.
plate tectonics, is that due to the water on the Earth?
No, that's due to the convection that we have, like a thin layer of oil boiling and you're getting heated in your frying pan on the stove. You can see these convection cells coming up. That
Right.
comes up from the heated core of our Earth, and it brings flows of material up. And as these spread out, they can drag the lighter material, the continents, they can drag those along on these convection cells as they expand and flow outward toward each other.
Huh.
And the presence of liquid water down in the mantle, can help with some of that, but it's not the major driving factor.
Right.
Right. And no pun intended, it was an earth-shaking discovery in the early
Yeah.
60s.
Fun was intended, let me tell you.
It's interesting. Tectonic comes from the Greek word for carpenter. Is that neat?
Would it be fair to say that the Western Hemisphere is moving west and the Eastern Hemisphere, which is Asia and Africa, is moving east? And they're going to conjoin on the other side?
They only have motion with respect to each other.
Well,
Right.
one plate's going under the other, and that's what causes the tsunamis. And
Subduction zones, and then they have expansion zones in the middle of the.
Yeah, and surprisingly, Ron, the plate that carries Australia also carries India, also making the Himalayas.
And if you look back, if you look at the coast, the western coast of Africa and the eastern coast of South America, they kind of fit together.
That's
and
right.
they're actually strata of leftover seashells and ancient life that match on both continents. And so that they used to be part of a single continent until a rift appeared there, the mid-Atlantic rift, and pushed them
Right. Something similar in Norway and also in the Appalachians. So they're cousins. They're cousins as the two continents drifted apart.
And the India subcontinent is pushing up the Himalayas, right? By going
Yes.
north.
Yeah, and it is surprising that, it's also associated with Australia. So Australia and India are also on the same plate.
Is that called the Indian Ocean Plate, you suppose?
Don't remember the name, but I've been reading Basin and Range again by John McPhee, and it's just really fascinating.
Seems to me that the Earth at one time was half land altogether and half water altogether. That would have been a little lopsided to me. Water is pretty heavy, but whatever. Interesting. There we are. There's our system.
Okay. Now, this is a picture, an illustration of Venus if it had the present day geology, its heights and its lows, but it had Earth's supply of surface water. And so it would look, this would be a map of what Venus would look like if it hadn't gone astray on the atmosphere.
The blue would be the water.
Yeah.
Yeah.
Apparently it had a lot of water like the Earth did when it formed.
God.
So it's very interesting. I see a lot of science fiction books and stuff in here.
Yeah.
Reminds me of Ursula Le Guin's Earthsea series.
I count about 5 continents.
It looks like the Philippines.
It does.
Yeah, right. A world of the Philippines.
So send this to Edgar. All right. What's the
Okay.
red on? Well, we're off. to-
Well, that was
moving
showing
out
you
now.
altitude.
Oh, I see.
Yeah.
And what is this?
This
Io.
is a fuzzy shot of Io. The significance of this picture is that it was taken by the approaching Juno orbiter on one of its closer passes. And it's now going to be one of the targets of Juno for a period of time here while they detail map the volcanoes.
Huh. So it's coming in for another close-up pass by. of
This
Jupiter?
is coming in for a close-up. I believe it's going to do a lot of close-ups. And they're going to monitor the change in orbit as it passes by, which will give us the internal structure of Io.
Hmm.
So it's an ongoing mission.
Well, what was it the Voyager that saw it first?
Io?
Yeah,
Yeah.
I think
the
they'll
one
live
that-
first.
Yeah. Well, the volcanoes were first seen by Voyager, but they were predicted by a UCSB astronomer, Stanton Peele.
Yeah.
Really?
Yeah.
Mhm.
Well, there were some pictures of moons with fans on the surface that were.
Yeah.
Was that ice or do we have?
No, that's the volcanic eruption.
Okay, well, I'm not seeing it on this picture.
No, this is not a very sharp picture.
Yeah.
No. Okay.
And there may
It's
not have been a
just-
very active one on the limb when they took this image.
Yeah.
Chances are good that Io never had any oceans.
Yeah, the discovery was made by someone named Linda Moravito or something, and she saw what looked like one of those little fiber optic lamps, perfect
Yeah.
little spread of things right on the horizon, and she pointed that out to people, and she knew what it was, but I don't think she was given the
I'm trying
credit.
to think of her name. She was at the U of A. I can't remember her name.
I thought it was
Portico,
Linda.
right? Portico, Chuck? Portico?
I don't
I don't know particularly who made that observation. I just remember Stanton Peele
Okay.
because I
I
took
think
some
it was
classes from him. So
Voyager was getting close. Portico noticed, that's her last name. I can't remember her first
Okay.
name. But
Jennifer,
she noticed-
Jennifer Porco.
Sounds close. Sounds good.
Yeah.
Now, Io is smaller than our moon, much smaller.
Yeah.
No, it's about the size of our moon.
Yeah.
Okay, and the concept involved, the phenomenon is being too close to Jupiter, and so it's wrenched.
Right.
It just
Well,
wrenched. What is
It's,
that called?
yeah, it's not just Jupiter. It's also the other big moons being in integer sequences of their periods.
Oh, they affected too.
Oh, yes.
Mhm.
Ganymede, okay.
It's like
Okay.
taking a rubber ball and squishing it in your hands. After a while, it'll get hot
Yeah.
and your hands will get sore.
Did I hear that it
This
makes
is-
a little ring around Jupiter?
There's a
Not-
ring of sulfur ions
Yeah.
because of the volcanic eruptions. Yeah.
So there's
And
probably
some of
enough
these
now.
other moons shed things, I think on Saturn, that the other moons pick up as they run around their orbits and pick it up. Anyway, this is showing an event that I don't think you can see from the West Coast. This is May 26th, early in the morning, just after Jupiter rises from Central Daylight Savings Time. You can calculate what it would be for the West Coast here in Pacific Daylight Time, but Jupiter hasn't arisen or come up over the mountains by then. But it's the transit of both Io and its shadow.
Mhm.
And there was an event that's fairly rare that a bunch of us went up to the gun club and saw a couple of years ago, where you had all 4 moon shadows on Jupiter's face at once.
yeah.
Plus Ganymede was also on the face of Jupiter. And so it looked like 5 moon shadows because Ganymede's kind of dark.
And you guys can see those shadows, those moons, and
Yeah,
you're
oh,
getting
yeah.
a telescope?
yeah.
If you have a good sky and a good scope.
No kidding.
Now,
Good sky is
this
critical.
This is 30 seconds of an arc, which is about what Jupiter is right now. But Jupiter gets up to 50 arc seconds on occasion.
Oh, okay. So somewhere I heard that the big red spot is getting circular, not oval anymore. It's
It
speeding up.
changes shape, it changes size, it changes color. The color cycle is like a 70-year cycle.
Really?
Yeah.
Okay.
There's a
I remember back in
hydrodynamicist
the-
up at Berkeley that came and gave a talk at UCSB probably 15 years ago. And he was predicting the great red spot's going to go away within 50 years at that time. So we've got another, 35 left. Keep your eye on the great red spot.
It was very red when I looked at it in the 60s.
Yeah.
It's been there 300 years or so, right?
Ever since we've been able to see it.
Yeah.
Chuck,
Well, that's-
Carolyn Porco.
Carolyn Porco,
Okay.
that's
Okay, so
Jupiter.
this is at 4:24 a.m. on the 26th. This is what you'll see when it's up an hour after that event from the West Coast. I missed out on an enlarged view of it, but this is still Ganymede down here, and Io is now on the edge of the planet where its shadow was in the previous night. So this is the shadow here, and this is Io. But when it comes up in the west, Io will be off to the, just leaving the planet.
Mhm.
and it looks like Ganymede would be behind and Europa.
Yeah, Ganymede, yeah, and Europa and Callisto.
Okay.
This is just there because it's a cool picture. It's one of the smallest moons of Saturn,
Helene?
Helene.
Well, now, recently, somebody said that they discovered all kinds of new moons around Saturn. There was over 100. Did they do the same thing with Jupiter that we just left?
Jupiter had jumped ahead of Saturn and went up to 95 moons a couple of months ago. And but then Saturn reclaimed the title. It's up to 145 now.
Yeah.
Wow.
Boy, this is a surreal rock we're looking at here.
Oh, I think the closer you get,
Gullies on it.
Reminds me of my face.
Yeah, I think you can get shots for that nowadays.
Okay.
It looks like it has erosion gullies on it.
yeah, a lot of, yeah,
That might just be gravitational, things rolling down slopes.
mhm.
Yeah, yeah.
A lot of fine stuff down here, dust or crumbled up stuff.
Tidally locked.
It's a cool picture.
Yeah. Markings and gullies, supposedly.
Okay,
Where are we now?
now
This is the
we
lagoon.
are-
Oh, the lagoon.
We are taking a pathway through the sky here to find a comet.
Aha.
And the Sky, or not a Sky Telescope, the Astronomy magazine has a bunch of signposts on the way. And the first one they point out is that they're easy to find. These are in Sagittarius, which is the summer Milky Way and the core of our galaxy. So it's very dense in these kinds of non-galactic objects. This is M8, the Lagoon Nebula. And this one.
And this would
is-
be early morning our time.
Yes. And this right now, but it'll be this in June and July or July and August, this will be the evening sky.
Mhm.
And then this is Bruce's picture of the Lagoon Nebula.
Ah.
Showing the lagoon.
Right.
Yeah, I sent that to you because, in fact, my email says that. One of my pet peeves is when they take pictures of nebula, they overprocess them, and you lose the contrast.
Well, that's not over processed, Bruce. That is just a long exposure to show a lot more detail.
Well, but the lagoon part of the Lagoon Nebula really doesn't stand out as strongly as when it's not quite so.
Right, but it's not a bright feature, so of course it gets overwhelmed when you take a longer exposure.
Well, here's.
But you're seeing a lot more detail. I mean, look at that comparison. I mean, you can see all the little folds and
Yeah.
wrinkles in the nebulosity.
I wrote down what Bruce wrote, and here's how he ended his email. It was taken before LED street lights from my deck on August 22nd, 2013, going on
Wow.
10 years ago with my Orion 127 millimeter deep sky stacker.
Well, the Deep Sky Stacker is software, but the 127 millimeter is a Maksutov telescope.
Mhm.
Okay, so a nebula is a big vast cloud of gas and dust. Star
Mhm.
nurseries. Okay, and then we're trying to find a comet that isn't
No.
normally visible.
No, this is what I should have put this chart first. This is what we're doing. We're looking for this comet, which is Comet Linear. It's not a bright comet. You have to dig for it, but they
Okay.
have a bunch of mileposts here. NGC 6822, 68118, 6835, 6836. And so rather than just have the names on a chart, I put up pictures of each one.
Mhm.
And this is this is
6559.
yes, 6559, a star forming region. So this is a long exposure to bring out the details in this, and you can see the real nice Barnard dark loops in here.
And there's a nice little analog of the Horsehead down there too.
Yeah.
Oh, is that the horse head?
No, it's not
No,
the
it's
Horsehead,
not.
but it's similar.
Not?
Yeah. The Horsehead is just one of
Yeah,
these kind of things.
It's just that, Ron, from the colors, you can tell that the nebula down below that's blue is reflection, and the one just above it that's red is an emission.
Yeah.
So hydrogen's re-emitting there.
Really?
Yeah, the blue is dust basically, and
Mhm.
the red is hydrogen.
Yeah. So
And the
stars,
black is probably both.
yeah, stars must be pretty darn hot.
But the
Yeah, the
blue
blue stars are really hot.
wow.
Yeah.
Well, the black is carbon, isn't it?
It's dust. We don't
Dust.
know, there's probably carbon in there.
Any dust will get thick enough to block light. Carbon's really good at it. I don't know that there are pure carbon star or carbon regions. I haven't heard about.
So just bare ass carbon atoms make dust?
Any
That's
Well,
kind of a technical question, Ron.
Say again?
That's kind of a technical question, isn't it?
Well, I posed the question several weeks ago. Dust to me means a bunch of particles that if you went down microscopically, they're pretty good size. I mean, there's a lot of atoms in them.
Yeah.
But you guys dispel that and said, no,
No,
it's
No, we're not
compound.
dispelling it. That's
Molecules.
a compound dust.
They're barely like molecules. Molecules are different atoms combining to form salt or
Yeah,
whatever, water.
water.
Yeah.
Yeah.
Well, that's more like, yeah, okay. Some of that's more like a compound, but yeah.
It's
We
pretty.
have some knowledge of this stuff. Where is this the same thing we're looking at here? No, what
No.
is this?
No,
This
this
is
is
a-
another NGC object.
This is a dwarf elliptical galaxy in Sagittarius, NGC 6822. It's orbiting our galaxy.
Mhm.
It's one of the mileposts, or what is it, mileposts on the way to finding it. This is a planetary nebula called the Little Gem, or 6818.
Mhm.
This is a Hubble picture.
Looks like the
Are these
same
visible
size.
with our scopes?
Say that again?
Are these things that you put up visible with our scopes?
Yes, they're all here because they're Messier objects.
Well,
no, some of
NGC,
them are. They're all
NGC, not
NGC.
Messier.
Yeah,
Right. No,
So-
I've seen Little Gem in a scope,
yeah.
amateur scope.
I
Looks
think
like
you
the
can see all of, well, I have a 18-inch telescope. I think you can see all of them.
Oh,
Yeah,
yeah.
that dwarf galaxy might be a little tougher than the others, but
Yeah.
Yeah.
huh.
Oops.
6822 you're talking about?
Yes, the dwarf galaxy.
Mhm.
So none of you gentlemen, I assume, are gonna try to find the linear comet anytime soon.
Not in this marine layer environment we're in.
and not with that finder chart. Man, that's horrible.
Yes,
Mhm.
I just put it in because it's so convenient instead of making
Yeah.
my own.
Now, is
So
that an
this
edge
is
on?
NGC 6836 and 6835.
Mhm.
An edge on galaxy?
One of them,
They're
yeah.
Edge-on galaxies. This is This is
Spiral.
36, and this
Looks
is
like a spiral.
35.
Yeah, so a face on and an edge on.
Yeah.
Like M81 and M82.
Yeah.
See, and these are listed here as 35 and 36.
Okay.
And we've looked at this. I don't think I put a picture up of this one. But anyway, this is the region where linear is, and this is May 22, so we're right about here.
Yeah, looks like its path is not very linear, Jerry.
No, it's not.
I'm gonna say that, yeah.
However, it's a geodesic and not a line.
Yeah.
Right, right.
And that linear stands for Lincoln Laboratory Near Earth Object Search. So
Oh,
that's
oh.
the system that found it.
I'll
Yeah.
be
It's
damned.
probably got, it's not just straight linear, because otherwise there are probably hundreds of linear comets. So it's got some other designation, C/2023, blah, blah, blah.
Thought we were talking Euclidean geometry here.
Yeah.
Wow, linear, okay.
So if you can't find it, there's all this cool stuff around here.
Yeah.
And all
That
those
you can
other,
mest for a comet.
Yeah.
all those other comets we had in the sky are gone or just disappeared.
Well, they're just dim now.
Yeah, well, same thing.
Yeah, comets are never gone. You can even find Halley's Comet out there if you have a large enough telescope.
Does it
floating in
come out
space.
of the Kuiper belt or the Oort cloud, or did they know?
It's in the Kuiper belt right now, I think.
Oort cloud would require a little longer version than
I
70.
don't think we can see objects in the Oort cloud from
Yeah.
here.
Are you talking about Halley? Because an
Yes,
interesting
yes.
thing about Halley's comet is it's just now starting its return. It has
Yeah.
reached its farthest point and made a U-turn, and now it's heading back
Huh.
for
Well,
the
if-
next appearance.
Mhm.
If they
In about
manage,
35 years.
That's right, yeah. Saw it in 1986 in Tucson.
Yeah,
my-
so it's like 38 years to the halfway mark.
Yeah,
well, if they manage to find the dreaded ninth planet, the big one out there that we think is there, is it in the Kuiper or is it way out in the Oort?
No, it's more Kuiper.
More Kuiper. That's
So
Kuiper
where it
is-
is an open question.
Yeah,
Kuiper is a ring and the Oort cloud is a big shell.
the
Yeah.
Kuiper is ring, but expanding as you get farther out. So it flares out into the Oort cloud.
Mhm.
And chances are every star out there has this same setup, doesn't it? Clouds like that and
I
rings.
wouldn't say every, but quite a few.
Yeah, as long as it's not in a globular cluster or had a close approach to another star to disrupt everything, then I think it's fine. Yeah, that could be like us.
Well, this looks like the CBSI.
This is our Helix Nebula.
looks like the helix.
It is
Oh,
the helix. It's NGC 7293, Caldwell 63.
okay.
So it's also called the Cat's Eye Nebula. Oh, no, it looks like the Cat's Eye Nebula
Mhm.
and the Ring Nebula and the Dumbbell Nebula. They're all things that present this type of structure to us. This is showing, this is a very deep picture of it and highly processed so that you don't saturate different parts. But you can see it looks like it's thrown off different layers at different times, and that's exactly what it did. Sometimes you can have a more recent explosion closer to the object, but it's going much faster. And then when it collides with the dust that was thrown off leisurely earlier, it creates a spectacular light show.
Discovered by Carl Ludwig Harding before 1824 and one of the closest nebulas to the Earth,
Yes.
according to your.
So this is, in contrast to a nova or a supernova, this is what happens to stars like the sun, where they just throw off their outer layers and they collapse into a white dwarf. So this is where you get a white dwarf. And right here, there's a little white dwarf that's responsible for all this
Right in the
chaos.
middle there, yeah.
Yeah.
Hmm.
And Tim just sent a comment. It looks like two offset rings in a backyard telescope, because you're not seeing all this detail.
Yeah.
Right, and if you look at the upper right section of this image, you can see a couple of galaxies. That's
Oh,
Yeah.
yeah. There's one there.
yeah.
And one to the left, yeah.
One
So
there.
Jerry, is this the helix?
This
Yeah.
is the helix, yes.
So one of my favorite students, Tim Becky, who's now studying cello at Curtis in Philly, took an image of this thing with the 24-inch, and he gave it to me as a present. I have it hanging in the house here. It's really beautiful. He's really good at imaging and adjusting colors and stuff like that.
Oh, good.
Yeah.
Well,
In Monteceros, right? In Monteceros?
I think that's where it is.
Yeah. You can see this with your eye in a very, very dark sky. You know, it's pretty bright.
It's in Aquarius. I think you're thinking of the Rosette. Is in.
I was
Yeah,
thinking
it is an
Rosette. You're right,
Aquarius.
Chuck. I was thinking the Rosette.
It's 650 light years away.
Okay.
do they also call this God's eye looking back at us?
Yeah, all kinds of things like that.
Wow.
It's quite large too. So if you're looking for it in a backyard telescope, you need a really dark sky because it's pretty low surface brightness. And you need to have a fairly large field of view. Otherwise, you're only going to be looking at a tiny bit of it.
Yeah. And maybe an O3 filter.
Yeah, O3 would really help.
Yeah.
Now out here, you can see dust clouds, dust.
Yeah.
And you can see that there's a brighter region of the dust. That could be light going from here and reflecting off of this. And so it would look like a ring moving out through there called the light echo. So this is estimated to be 10,600 years old.
Wow.
But you can tell exactly because the white dwarf inside will give you an age for it.
And you can estimate if you do spectroscopy, you can get a velocity towards us, at least, of the stuff, towards and away, and then you can extrapolate backwards to when it was expelled.
The expansion rate they gave for this is 31 kilometers per second.
Okay.
So it's doing 31,000 meters a second. Pretty good.
I think that's how fast we go around the sun, if I remember right. Something like that.
I don't recall that.
Really?
Yeah, about 30 kilometers per second.
So that was a white dwarf, but not a nova or a supernova.
Here we go.
And nova and supernova. A nova will occur when a white dwarf consumes too much energy. So a white dwarf can do something again after it becomes a white dwarf, if it's part of a binary star. And
that's kind of a weird phrasing, consumes too much energy. I think they mean accretes too much mass.
Yes.
Yeah, I think I like your word.
Hill thing. Of course, Mr. Einstein, he put it together, didn't he? They're the same. Yeah, your dog disagrees.
So anyway, I'm having a sneezing fit. Would you take this over, Chuck?
Okay, so you have a white dwarf that's in a close orbit with a binary companion, and it can accrete material. You know, their Roche limits overlap, and so it can suck material off of it, and that accumulates on the surface. And it's, of course, now it's being accreted onto a very dense object, so it gets compressed. And when you get enough of it, and it's compressed enough that it reaches basically thermonuclear ignition temperatures, it blows up, and you get a really bright explosion. And so the star seems to brighten up, and from going from a white dwarf that's not visible to something that is visible, it was called a stella nova, a new star. And so that's where we get nova. It suddenly appears and then it seems to go away. And they can be repetitive because it doesn't necessarily destroy the white dwarf. So you can have these repetitive ones that blow up every, century or every couple of decades.
Yeah, not predictable.
Right.
Yeah.
And now it could also, if enough of it accumulates, and it goes over, I think it's the Chandrasekhar limit, then you can get a type 1 supernova. And that's the standard candle one, because they all happen at about that same mass. And so they get to about the same peak brightness. And so those are the ones you can use as a standard candle, the type 1 supernovae. And they're from these white dwarf explosions. And that detonation will destroy the white dwarf usually. And then you can also get these type 2 supernovae, which is where you have a really massive star that makes iron in its core. And it's called a core collapse supernova, because now the core collapses. End result is an explosion that blows the star's guts all over the sky. And those vary in brightness quite a bit, depending on the star that does it. And there is a type 2 supernova that's visible in M101. I think Jerry added a picture of that. We
Yeah.
saw that on Saturday night.
Yeah.
In one of the arms of M101.
The
It wasn't
two,
this one, but it's the next one.
yeah, this is one that was from a few days ago. They list these in order, GFO. So this is in galaxy NGC 4995, which was May 18, it was spotted. And then I added this one,
Yeah.
which is in M101, because this one occurred. No, that was May 18. This is on May 19. So we got a couple of nice supernova here, but there were other ones in between. So you go from, whoops. So you go from GFO to HI, now it's down to I. So there have been at least 2 supernovas in between these other supernovas.
Well, even more, right? Because
Yeah,
it's
yeah, it's cycle
G,
through
A,
these
B, C,
numbers.
D, it's a whole bunch.
Yeah,
There's thousands found each night.
yep.
But this one was readily visible with the Melancam in like a 28-second exposure.
Oh, you got it?
Yeah. Yeah,
Where
we were
were
showing
you?
it to people up in Los Olivos before the marine
that's
layer
right.
came in and got us.
Before the what?
The marine layer, the
Oh.
clouds
Mm,
coming up the San Ynez River.
yeah.
Yeah, I looked out here about 9 o'clock and the sky was stunning, and an hour later, forget it.
Yeah.
Well,
Hey,
gentlemen,
Gray.
isn't our solar system made up of the remnants of a blown up star that ran out of fuel? Or how in
Yeah.
the world did we get a new star called the sun if it was all used up?
Well, there was a cloud nearby, of hydrogen gas, and the shock wave from the supernova explosion, along with some of the flying material, came and triggered new star formation.
Okay,
Yeah, these elements are not really used up in a destructive way. They're used up by making new elements. And then new elements is what the Earth and Sun is made out of.
But old Fe, that's the signal for iron, spells the
Yeah.
death. And yet we got iron all over the earth. That's
Yeah, a lot of
different-
supernovas has gone off before our star and planets were made.
And remember, Ron, this has to be a star that's like 8 times the mass of the sun, at least, to blow up in a supernova like this. So it produces a lot of iron. I mean, the Earth is just a tiny, tiny, tiny thing.
Really? But there's never been a case of a white dwarf accreting stuff from its companion and actually blowing back up and becoming a normal star again like it was?
No, it blows up in a type 1 supernova.
That's what it does rather than
Yeah.
returning to normal.
No, because it doesn't have a lot of hydrogen and helium, anymore in its core. Its core is now carbon and other things.
I'm saying getting it, from the dust or the other
Yeah,
star.
but it's already different in structure. It's not a gas ball anymore. So
Well, once they're dead, they're dead. It's
Yeah.
over.
Yeah, they're a solid.
And there's a bunch of them. They're all depending on how much mass, right? Whether you get a kilonova, a supernova, a hypernova, just a regular nova. I guess they're all novas, aren't they?
yeah, some of
Oh,
those
yeah, I
are
didn't-
collisions, like a kilonova is a collision between 2 neutron stars.
Oh, it is.
Yeah.
And that's another way it could go other than white dwarf. Is that the next step below white dwarf?
Well,
And
Neutron
then-
star is the next step below. So yeah.
And then from there.
Once it goes in a type 1 supernova, you may be able to get that tends to destroy it because I think it's carbon and it just triggers all of that. So I don't think you get neutron stars from a type 1A.
But beyond that, it's black hole time.
Yeah.
Neutron star. Okay.
Actually, this compares the May 19, 2023 with the March 30, 2009 supernova in M101 in roughly the same area.
Well, was that a supernova? I mean, there is a star visible there. Is that just a progenitor?
I don't know.
What if they name the
I didn't
arm?
capture the text of that to that point.
Yeah.
Well, it looks like there's still more to talk about in future shows, gentlemen, but we've run out of time here. And remember, SBAU.org is how you find out all about us. And we're going to welcome Dr. Ski Antonucci, a legendary UCSB professor, 2 Fridays away at 7:30. Come early, and 7, we do a half-hour show inside Gladwin Planetarium up at the museum. And gentlemen, we got one more shot together before the big Friday meeting of the 2nd of June. So you got plans to haul your instrument out and under the cloud cover and try to see something. Anything going on real fast, outreach wise that you can talk us about?
Tuesday is Telescope Tuesday at Community Rail Marketplace. Weather forecast doesn't look great. We'll see. And then Thursday is Hope School with a moon observing night, and we'll see what happens there.
That Tuesday sounds delicious. You can have a taco on the way there.
Yep.
All right, Jerry and Tom and Chuck and Bruce, thank you very much. Take care of your wives and yourselves, and don't get COVID. You can still do it. You know, we'll see you next week on the radio. Boy, old habits.